So just to get started, let's jump into LabVIEW. So this is the LabVIEW Getting Started screen. Basically, if we're going to create a project in LabVIEW is a set of files located in a directory on your hard drive. In addition, there's a file called the project file, which is like a map to that project directory, which LabVIEW uses and maintains to keep track of all of your program pieces and bits. So we're going to go New, to bring up the new file or project wizard. We're going to choose Project from Wizard. We're going to choose a CRIO robot project, which is something that's available as long as you've installed the FRC project. Sorry, the FRC software. Next, it's a wizard, so it's asking us for some information, so we're going to tell it where we want our project and what we want to call it. So I'm going to call this the Atlanta demo. We have to specify our IP address, so I'll use the one that I'm used to typing in, 843. And then when you click Finish, it goes and builds the project. It creates all of these files, it links them up, and it will open them up on the screen. So a topic for a later discussion, and this is one of the things I actually put on one of our tip jar videos, if you want to check them out afterwards, is making the decision between whether to use the basic environment or the advanced environment. And I think they're a little bit misnomers. In fact, I was earlier talking to the individual at National Instruments who wrote them. And in fact, maybe basic and advanced weren't the right names for them. I think that almost universally, those of us who have a lot of LabVIEW experience prefer the advanced project. What that gives you is a lot of ability to scale your code and to have multiple programmers work together. However, this is an introductory demo, so I'm going to show the bare minimum amount of effort and understanding required, and for that we're going to use the basic demo. So you've created our basic project. We see the Project Explorer is open now. It lists underneath RT Compact Rio target with the IP address that I specified, a series of programs, a series of VIs. A VI is short for virtual instrument, and that's a piece of LabVIEW code. Basic robot main is the file that contains our main program. So we're going to open that up. It's going to pop up, and what we're going to see is the front panel. So in this case, because this program runs on the Compact Rio, it doesn't run on the laptop, there is no real interface. It just simply shows one button which allows us to turn on or off the vision. But this is not really the code. This is like the front panel or the window or the face of the code. An analogy I like to use, if you picture an oscilloscope, on the front of an oscilloscope are a bunch of buttons and graphs and knobs. That's the front panel. If you were to look behind that front panel, you'd see all kinds of wires, integrated circuits, and various terminals. That's the heart of the thing. That's the code. The code in LabVIEW sits in the block diagram. Okay? So the block diagram looks like this. Really what we have are a bunch of, as a former colleague of mine, a CAD individual said, it looks like just a bunch of pretty wires and squares. And that's really what it is. In this case, the pretty wires are data. That's how inputs and outputs are connected. And the squares are functions. So a function might be turn on the motor. A function might be read the joystick. A function might be multiply by 10. All of those functions, inputs, and outputs are represented graphically in LabVIEW. You don't have to create any text when you're programming in LabVIEW. So it's not my goal here to give you a tour of all the details behind how LabVIEW works. I want to show you what is necessary to do a relatively simple activity, which is to take the sample code, which already does the arcade drive, and add a third motor, which is triggered by a joystick. So in order to do that, we need to open that third motor. All of LabVIEW is programmed in the same way. Basically, you open a peripheral, you read from it, or you write to it, and then later on you close it. So we can see here, this guy, this collection of data, you can see it's called drive open 2 motors. It's got a Jaguar underneath, which means it's a Jaguar motor controller. You see it's got PWM 1 and 2 as the left motor and right motor inputs, and one of them is inverted and the other is not. That's all the information you have to tell LabVIEW to get 2 motors ready to be driven. And then you can decide later whether you want to drive them in tank drive or arcade drive. But if we look here, inside this portion of the code, called tele-off-execute, we see that another block called arcade drive is what's actually talking to these motors. And if we follow this block back, this thick pink wire is connected back to the open motors. So again, all these wires are used to carry data around. So we opened the two motors, we connected them up, we then do an arcade drive. So what I need to do now is I need to open a third motor. Everything in LabVIEW, again, is done graphically. So to access a new function, a new block, I right-click, and I access my WPI robotics library. Inside there, I have, and I'm just going to pin that down. Oops. Go to my WPI robotics library, pin that down with the thumbtack, because these are the tools that I'm going to be using over and over in this demo. You see that they're all organized into name palettes with little pictures. So I'm going to choose robot drive. And I know that what I want to do is open one motor. That's actually an advanced function. So I go to the advanced subpalette, go to motor control, and then here I've got my motor functions. Just like I said a second ago, there's a three-step process. Open, set or read, and control. And close. So I'm going to open up this motor. I'm just going to pull it out here. And because there's a little bit of documentation, I'm just going to move things around. So this is going to open up a single motor of type Jaguar. But I need to specify one thing. I need to specify which PWM I'm using. So in order to do that, I'm going to use what's called the context help. So this is another environment pack, another piece of the environment, which tells us how to use this stuff. So I'm going to choose my PWM channel. I'm going to create a constant. What that allows us to do is choose which PWM is going to be used by this motor. And since I have a choice of 10, I've already used 1 and 2 in the first part, I'm going to use PWM 3. So the other thing that I wanted to do is I wanted to use a joystick button to control this motor. So I've got my motor opened. I'm going to need to use the set speed to turn it on or turn it off. And I'm going to put that inside my tele-op code. Next, I need to connect up this pink wire so that I know which motor I'm setting. And the final piece of the puzzle was to use the joystick control. Okay. Well, this has already been set up in this demo to read 2 axes from the joystick so that you can do arcade drive. But what we need to also do is read the buttons. So we navigate back to our robot drive palette. We have some joystick functions. And the joystick get function we're going to use to connect to our existing joystick, which has already been set up. And we're going to get the value out of one of our buttons. So in order to do that, we have to pick which button we're going to use. For that, we're going to use an unbundled by name. What that does is pull out from this collection of all kinds of buttons, 12 of them, the exact button we want to use. So if I use button 1, that's going to give me a value. So what is a button value? Well, it's either on or it's off. It's either pressed or not pressed. So what I need to do now with this button value is, based on whether it's true or false, send either a 0 speed or a non-zero speed. So if we were programming that in C, that would be an if-else kind of statement. In LabVIEW, an if-else is called a case structure. And again, because it's graphical, we don't have the ability to type if-else. We have to use something visual on the environment. So we take our button value and connect it to this little question mark terminal. It's known as the conditional terminal. So if the button value is true, the true case will execute. If the value is false, the false case will execute. So what I need to do now is just put in speed. So speed is set as a number, something between plus and minus 1, where plus 1 is 100% forward, minus 1 is 100% reverse. So all I have to do is create a numeric constant